In our second example of example 2 with section 8.4, we're looking at still finding angle measures. So in this part B of this question, it says find the measure of angle ZXY. So we start at point Z, we follow Z down to X along this line, and then we go from X over to Y. Okay. And so we're talking about this angle right here, okay, which has already been labeled as 4x plus 7 degrees. So we're wanting to find out what that particular angle is. Now, hopefully what you also notice here is that we have another angle, which is WXZ, following those points right there. It's this angle here, which is labeled as a 35-degree angle. Now, the combination of angles ZXY and WXZ is equal to, it says right here with this little box, a 90-degree angle. So what we have are two complementary angles to each other. So what we can do is we can come over here and we can say that the measure of angle ZXY plus the measure of angle WXZ should be equal to 90 degrees, because when you have two angles that are complementary to each other, they're always going to be equal to 90 degrees. So in this example, we know that the measure of ZXY, they've already told us, is 4x plus 7. So I'm going to replace this measure ZXY with 4x plus 7 degrees. Now, we're also told in our diagram here that WXZ is a 35-degree angle. So I'm going to replace that measure of WXZ with 35 degrees. And then that should be equal to 90 degrees. Now, from here, what I'm going to do is I'm going to try to combine like terms. So I have this 7-degree here, and I have this 35-degree here. They're both on the left-hand side of the equals. So I can combine those two things together to simplify things a little bit. So the 4x, we're going to leave it as it is. It's going to be still right here. Then we have 7 degrees plus 35 degrees. Now, when we combine 7 and 35, that's going to give us 42 degrees. And that's going to be equal to 90 degrees. Now, from here, what I want to do is I want to isolate the term that contains the variable x. So I want to get this 4x by itself on the left-hand side of my equals. So what I need to get rid of is I need to get rid of this plus 42. So to get rid of it, I'm going to subtract 42 degrees on the left-hand side of my equals. Now, what I do on the left-hand side of my equals, I make sure I do on the right as well. So I'm going to subtract 42 on the right. Now, the 42s on the left are going to cancel out. It's going to leave me with 0 there. And the only thing I'm going to have remaining on that left-hand side is that 4x. And that's going to be equal to 90 minus 42. Now, I'm going to go over here to the side. I'm going to take 90 minus 42. 0 minus 2, I can't do it. So I'm going to borrow 1 from my 9, make that an 8, carry the 1 over, and call that 0 a 10. So 10 minus 2, it's going to give me 8. 8 minus 4 gives me 4. So that's going to leave me with 48 degrees. Now, from here, what I want to do is I want to solve for x. So I need to get rid of this coefficient of 4 that's in front of this variable. So 4x means 4 times x. So to break that apart, I'm going to do a division, and I'm going to divide by what I'm looking to get rid of, which is 4. Now, what I do to one side, I have to do to the other. So I'm going to divide this side by 4 also. So 4x divided by 4, the 4's will cancel, leaving me with x. And then 48 divided by 4, that's going to be 12. So x should equal 12 here. Now, we were told that the measure of angle, in this case ZXY, is equal to 4x plus 7 degrees. So what I'm going to do is we found out already that x is equal to 12. So I'm going to replace the x in this algebraic expression with 12, and I'm going to solve for my angle. So I'm going to say 4 times 12 plus 7 degrees. Now, order of operation says that I'm going to multiply first here. So 4 times 12, that's going to give me 48 plus 7 degrees. And these are all degrees as well. So when I take 48 plus 7, that is going to give me 55 degrees. So the measure of my angle ZXY in this problem should be 55 degrees.